Hello everyone, welcome to another video. In this video, what we are going to focus on is solving some multiple choice questions. These questions are based upon the unit of measurement. So let's begin. The figure above, not drawn to scale, shows a sector of a circle centered O. The length of the minor arc PQ is 5 centimeters. What is the circumference? So what we want to find is the circumference of the circle, right? What we know is that we have a sector, we have a sector angle, we have the length of the arc PQ, which is 5 centimeters. What do we know? We know that a sector is a part of a circle. So let's make a quick sketch. So if we have a circle, right? And our circle has a center, right? So let's say that this is O here. What we have a sector that has 45 degrees. So how many sector can we get out of a whole circle with length of arc length 5 and sector angle 45 degrees? So we'll divide up the circle into halves. So that's 4 quarters. And if we split each quarter into half, then that will give us the angle 45. So we can split this quarter into halves again and split this one into half. So what we're saying is that each of these angles here is going to be 45 degrees, 45 degrees, 45 degrees, each of them, all the way around. All right, so you realize that we would have 8 sectors in a hole that has a center angle being 45 degrees. That means the arc length here are 5. Each arc length here is going to be 5 centimeters. Right? So how many sectors we have in all? We have 8 of them, as you can see. So 1, 2, 3, 4, 5, 6, 7, 8 sectors. So what I'm saying is that the circumference of the circle is going to equal to the number of sector, which is 8, times the length of one of the sector, which is 5. And 8 times 5, that's going to give us 40 centimeters, right? So the circumference of this circle is going to be 40 centimeters. On to our next question. How many kilograms are there in 1/2 ton? What do we know? We know that 1 ton, right, is equal to 1,000 kilograms. Now they are asking us, in 1/2 ton, how many kilograms is that going to equal to? That's going to equivalent to half of this 1,000. So it's going to be 1,000 kg divided by 2. That's what it is equal to. And when you simplify this, all we'll get is just 500 kilograms. So therefore, 1/2 ton is equal to 500 kilograms. So our answer would be C for this one. Next problem, we are given 2 shapes, a rectangle and a square. And the question is, which of the following statement is true about the area of the figure A and figure B? So figure A here is a square. How do you calculate the area of a square? The area of a square, so area of a square is going to equal to the length times the length. What is the length? The length here is 4. So it's going to be 4 times 4, which is going to equal to 16. And because you're dealing with area, you have to remember the unit, which is squared centimeter. All right? Then now we need to find the area of the rectangle. So we know that the area of the rectangle is going to equal to length multiplied by the width. What is the length? The length here is 8. So it's going to be 8 times the width. The width here is 2. So it's going to be 8 times 2. What is 8 times 2? That's going to be 16. Remember the unit, it's area, so it's going to be squared centimeter. Now, when we look at both area, what do we realize? The area of the squared is equal to the area of the rectangle. So let's look for that statement. Here in A, it says the area of the square is equal to area of B. So our answer is going to be A. For our next question, it says 350 milliliter expressed in liter is. What do we know about milliliter and liter? What we know is that we know that 1 liter, right, is equal to 1,000 milliliter. Now they give us 3,500 milliliter. So they're saying 3,500 milliliter is equal to how many liter? That's going to equal to 3,500 milliliter divided by 1,000. Right? When we divide that out and simplify that clearly, you see the 0 will take out this one, that 0 will take out this one. 35 divided by 10 will give us 3.5 liter. All right. So our answer here is going to be B. For our next question, it says the volume in cubic centimeter of a cube of edge 4 centimeter is. What does a cube look like? A cube is just a 3-dimensional shape with all the sides of equal length, right? So let us draw a quick sketch of what a cube look like. So this would be a sketch of a cube. Now they tell us that the edge is 4 centimeters. So they are saying that this side here is 4 centimeter. The height here is 4 centimeter. Right? And this side around here is 4 centimeter. That's what they are saying to us. So they want us to find the volume. So the volume of a cube now is going to equal to V for volume is going to equal to length times length times length, which is going to equal to 4 times 4 times 4, which is going to equal to 4 times 4, that's 16, and 16 times 4, that's going to give us 64. Remember your unit, because it is volume, it is going to be cubic centimeter. So our answer here is going to be C. Now here we are given a shape, which is a cylinder, right? And it says the diagram, not drawn to scale, shows a cylinder of a radius 3 centimeter and height 7 centimeter. The curved surface area of the cylinder is, what do they want us to find? They want us to find this part here. That part represents the curved surface area. They want us to find that area there. All right? So there's a formula for curved surface area. What we know is that curved surface area, right, is going to equal to 2 times pi times the radius times the height. That's what curved surface area is. What do we know about this question? We already know what r is, we know what h is, so we're going to substitute. So it's going to be 2 times pi times r. What is r? R is 3. So it's going to be times 3 times h. What is h? That is 7. All we need to do at this stage is to simplify, right? What is 3 times 7? 3 times 7 is going to give us 21. And what's 21 times 2? That's just going to be 42 times pi. That's just 42 pi. So the curved surface area here is going to be 42 pi, but you must remember your unit. So your unit is going to be squared centimeter. Next, the diagram not drawn to scale shows a cylinder of radius 4 centimeter and height 9 centimeter. The volume of the cylinder is, what does the volume of a cylinder equal to? That's going to be volume is going to equal to pi r squared h, right? So what do we know? What are the values we have for this formula? We know what r is, we know what the height is. So the volume is going to equal to pi times r squared, which is going to be 4 squared, times the height, which is going to be 9, right? All you need to do is to simplify this and you're finished. So it's going to be pi times, what's 4 squared? 4 squared is just going to be 16 times 9, right? And what's 16 times 9? That's just going to be 144 times pi. That's going to be 144 pi. And because it's volume, you have to remember that volume is measured in cubic centimeter. So it's going to be cubic centimeter, right? So the volume of this cylinder is 144 pi cubic centimeter, which answers that that's going to be D in this case. All right, and we're finished for that one. So here we're given a compound shape. So the question is, the figure above not drawn to scale shows a square surmounted by an isosceles triangle. The height of the triangle is 12 centimeter and the length of the square is 10 centimeter. The total area of the figure is, so here we can split up this figure into two. We can split it up into figure 1 and split it up into figure 2, right? So we know that figure 1 would be a square. So we know that figure 1 is just a square. What do we know about square? All the lengths of a square are equal. They tell us that, so it is 10 centimeter. So therefore, you can quickly calculate the area of the square. So we know that the area of the square is going to equal to length multiplied by length, which is going to be 10 multiplied by 10, which is going to equal to 100 squared centimeter, right? That's what we know. Now, what's the area of figure 2? We know that this is an isosceles triangle, right? So what do we know about isosceles triangle? Let's make a quick sketch. What else do we know? They give us the height, right? They tell us the height. So they tell us that h here is equal to 12. What's the length of the side? The length of one of the side is just 10 centimeter. So how do you find the area of a triangle? The area of a triangle is equal to half times the base times the height, right? So it's going to just substituting these values into the formula. So the area is going to equal to half times the base. What's the base? The base is 10. So it's going to be half times 10 times the height. What's the height here? The height is 12. Right? So here, the area is going to equal to, what's half of 10? Half of 10, that's going to be 5. So what you end up with here is just 5 times 12. And what is 5 times 12? 5 times 12, that is just 60. What's the unit? You're dealing with area, so it's going to be cubic centimeter. Sorry, squared centimeter. Now, what's the area of the entire figure now? It's just going to be the area of figure 1 plus figure 2. So we're going to add them up. So therefore, the area of the figure. So therefore, the area of the figure is going to equal to 100 plus 60, which will give us a final answer of just 160, right? So our answer here is going to be C, which is 160 squared centimeter. Next question. A hiker starts a journey at 8:30 and arrive at his destination in the same time zone at 14:30 on the same day. If his average speed is 40 kilometers per hour, then the distance in kilometer for his journey was. What do we know about speed and distance and so forth? We know that speed is equal to the distance divided by time. That's what we know. So if we know that speed is equal to distance divided by time, and they want us to find the distance, then we could transpose this formula to say that the distance then is going to equal to speed multiplied by the time. Right? So what do we know about this question so far? We are given the speed, which is 40 here. We know that, so we can plug that into our formula. So we know that the distance is going to equal to the speed, which is 40, times the time. Do we know the time at this stage? No, but we know the time when he started the journey and when he reaches the destination. So that therefore we need to calculate the time. So the time, which is t, is going to equal to the time when he finishes or reaches the destination, which is 14:30. Subtract the time when he started, which is going to be 8:30. So, and 14 minus 8, that's going to leave you with 6. So the time here you can see is therefore time is going to equal to 6 hours, right? So it's just a matter of now replacing t in the formula with the 6 hours. So it's going to be 6 here. So therefore, the distance is going to equal to 6 times 40, which is going to be 240 kilometers. Right? So our answer for this problem here would be B. To our next question. The perimeter of a square is 36 centimeters. What is the area of the square in squared centimeter? So what do they give us? We know that, this is what we know. We know that if we have a square, right? Let's make a quick representation. We know that if we have a square, all the lengths are equal. So for example, let's use a letter. Let's call the length L. So if this is L, this is L, this side is L2, this side is L. Now we know about perimeter, right? Perimeter is the sum of the distances around the shape, right? So if we should write out this in terms of a formula, we'll realize that the perimeter of the square would equal to length plus length plus length plus length, which can be simplified to be perimeter is equal to 4 length, right? So 4L. So that's what we know. Now we were given the perimeter. The perimeter here is 36. So what they are saying in the problem here is that P, which is the perimeter, is equal to 36. That's what we know. Centimeter, right? Now they are asking us to determine the area of the square. So before we can determine the area of the square, we need to know the measurement of the length, right? Now, since that we know that perimeter is equal to 4L, and perimeter here in the question is equal to 36, therefore we can equate this part of these two formulas, since both P are equal to these. So we are saying that therefore we can conclude that 4L is going to equal to 36. And from this equation now we can solve for L. So solving for L, we know that we can divide both sides by 4 and divide this by 4. So therefore 4 will cancel out 4 here, leave you back with L, and 4 into 4, 1, 4 into 36, that will give you 9. So the length of one side of the square is going to equal to 9. Now that we know what the length is, we can now go ahead and determine the area of the square. So what we know is that the area of the square is going to equal to the length multiplied by the length, which is going to equal to 9 times 9. And 9 times 9, that's going to give us 81, right? And what's the unit? The unit is this, squared centimeter. So which one is that? This is going to be D. AOB is a sector of a circle with angle AOB equal 45 degrees and OB is r centimeter long. The area of the sector AOB in squared centimeter is, so what do we know? We know that the area, right, of a sector, right, is going to equal to theta, which is an angle that is given inside of the sector, out of the total amount of angle in the entire circle, which is 360 degrees, times pi r squared, which is just the area of the circle. Now, what do we know about this question? Do we know what theta is? Yes, theta is going to be this value, which is 45 degrees. So all we need to do is to substitute that value into our formula. Do we know what the length of one side of, well, do we know what the radius is? Yes, the radius is given as r. So technically we have it already. So this is going to be 45 divided by 360 times pi r squared. What's 45 over 360? 45 over 360, that's just 1/8 times pi r squared. So that's just pi r squared. So the area of the sector is just going to equal to 1/8 pi r squared, right? And that answer here is going to be B. And here we are given a trapezium, and we are asked the area of the trapezium shown above, not drawn to scale, is, how do you find the area of a trapezium? The area of a trapezium is equal to 1/2 times the sum of the parallel lengths, which is going to be A plus B in this case, times the height, right? So these arrows on the diagram shows that this side that has 5 and this side that has 10 are parallel to each other. So any one of them can be A or B, right? And what we know is that the distance between the two parallel sides is going to be the perpendicular distance, which is going to be the height. So here you can see that 3 is equal to H, right? Let's say that 5 is going to equal to A and 10 is going to equal to B. So all we need to do is to substitute these values into the formula and simplify, and we are finished. So the area is going to equal to 1/2 times A plus B, that's just going to be 5 plus 10. Remember your bracket, multiply by the height, which is going to be 3, right? So what we know is that the area is going to equal to 1/2 What's 10 plus 5? That's just going to be 15, right? So that's going to be times 15 times 3. What is 3 times 15? 3 times 15 is going to equal to 45. What is half of 45? Half of 45 is just going to be 22 and a half. All right? So the area of this trapezium is going to be 22 and a half squared centimeter. So our answer here is going to be A. The area of a triangle is 54 squared centimeter and its perpendicular height is 12 centimeter. What is the base? So let's make a quick sketch of this. We know that we have a triangle, right? Let's say the triangle is a right angle triangle. They didn't tell us that, but we're just making a sketch to represent. So we have a triangle. What we know from this question, the perpendicular height is 12. So they are saying that, all right, this side here is going to be 12 centimeter, right? And they are asking us to find the base. So this side down here that it sits on would be base. So that's what we want to find. And what else do they tell us? They tell us about the area of the figure, which is equal to 54 squared centimeter. That's all the information that we know. So what's the formula to find the area of any triangle? The area, what we know is that the area, right, of the triangle is going to equal to half times the base times the height, right? When we look at this formula, what do we have out of it? We know what A is. So in this formula, we can replace A with 54. So it's going to be 54 is going to equal to 1/2 times B, which we want to find, times the height. But what is the height? The height, we know that is going to be 12. So it's going to be times 12. From this now, you just use up your algebra skill to solve for B. What's half of 12? Half of 12 is going to be 6. So on this side, we're going to have 54 is equal to half of 12, which is 6, and 6 times B, that's just going to be 6B. Right? And from here now, to determine what B is, it's just a matter of doing the opposite, which is to divide both sides by 6 here. So 6 into 6 will give us 1. What we left back with is B. And 54 divided by 6, that's just going to give us 9. And remember your unit, which is centimeter. So we are saying the base of the triangle is going to be 9 centimeter. This answer is going to be B. Now to our next problem. We are given a shape here, which is a parallelogram. It says the area of the parallelogram shown above, not drawn to scale, is. So what they want us to find is the area of this shape. So how do we find the area of a parallelogram? The area of a parallelogram is equal to B times H. That's what we know, right? Where B is going to be the length of the parallel side, right? So here, if you notice, this 12 here is going to equal to B, which is the base that it sits on. What's going to be the height? The height is going to be the perpendicular distance. So 4 here is going to equal to H. So it's just a matter of substituting these two values into this formula and simplify. So area is going to equal to 12 times 4. So the area is going to equal to, what is 12 times 4? That's just going to be 48. What the unit that you're working with here? Centimeter. So the area is going to be squared centimeter. All right. So you look for that one, and that would be B. The distance around the boundary of a circular swimming pool is 66 meters. The radius of the swimming pool in meters is this 66. What does it represent? This 66 represents the perimeter of the circle, which is what we call the circumference. Because think about it. They tell us the distance around the boundary of a circular swimming pool. So let's make a sketch of that. Let's say we have a swimming pool that looks like circular, right? It's not a perfect circle. So if we want the distance around it, then they are talking about the pyramid, the circumference of the swimming pool. So in other words, what we know is that how do we find the circumference of a circle? We know that the circumference of a circle is going to equal to 2 pi r, right? That's what we know. So the circumference of a circle is equal to 2 pi r. Now, we know that the circumference was given, right? So in this problem, what we are saying is that the circumference is equal to what? 66 meters. That's what we know. Now, they ask us now to find the radius, which is, they want us to find the radius. So look here. We can simply find the radius by equating this side of these two formulas here. Because you can see that C is equal to 2 pi r, which is the circumference, and C is also equal to 66. So this implies that 2 pi r is therefore equal to 66. And from this now, this is just an equation, we can now determine what r is going to be. So we can now find the radius. What is happening to the radius here? The radius is being multiplied by 2 pi. So we can do the opposite, which is to divide both sides by 2 pi. So here you realize that 2 pi will cancel 2 pi. That leaves you back with just r, which is the radius. And you can see that 2 into 2 here is 1. 2 into 66 will give us 33. So our final answer here is going to be 33 over pi. Which answer is that? That's going to be C here. Girl leave home at 6:10 hours and arrive in school at 7:40 hours. She travels at an average speed of 30 kilometers per hour. What is the distance of her home from school? So what do we know again about speed and distances and time? We know that speed is always going to equal to distance divided by time. So from this formula, we can always manipulate it to find what distance is. Since we want to find the distance, we can transpose this. So you can see that distance is going to equal to speed multiplied by time. Right? What do we know about this question? We know we want to find the distance. Are we given the speed? Yes, that is given. The speed is given as 30. So that's going to be 30 times whatever the time is. Are we given the time? We are not given the time, but we are given the time period. So we can use the time period to determine the actual time. So we know the time is going to equal to the time when she arrives at school, which is going to be this time here, which is 7:40. Subtract the time when she leaves home, which is going to be 6:10. So when we subtract these two times, 40 minutes minus 10 minutes, that leaves us with 30 minutes, right? And 7 hours minus 6 hours, that leaves us with 1 hour. But this time here is written in hours and minutes, but we can convert this minutes. 30 minutes in terms of how hour is what? That's just going to be half of hour. So this here, the time then is therefore equal to 1.5 hours, right? That's what we know. So that's just 1.5 hours. So since we know that the time is 1.5 hours, then it's just a matter of multiplying 30 by 1.5, right? So distance is going to equal to 30. We can quickly change this mixed number to improper fraction, and 1.5 is just the same thing as saying 3/2, right? And that makes us easier to calculate here. So this is saying what's half of 30 here? Half of 30 here is going to be what? 15. And what's 15 times 3? That's what's going to be 45. Right? So remember that distance is measured in kilometer. So here, this is just going to be 45 kilometer. So our answer here is C. Thank you very much for watching, and do enjoy the rest of your day.